Morning, my name is Gaurav Singh Rathod. My roll number is 20951A1223. I am from Information Technology branch. Today we are going to discuss the topic uh, what is meant by a database. So what is a database? A database is an organized collection of data, information and records. So what is the purpose of database? So the purpose of database is information that a person needs in person, business and social religious life, and the power and the purpose of information is not only in collection and finding them but more importantly in using them. So there are two kinds of databases: structured database, free-form databases. It is called a structured data in which a record or files of information arranged in uniform format. These databases are usually storage of information with similar entries such as a list of a person born in a country, a medical database of patient data, an inventory database of companies and many others. Free-form databases. It is a loose collection of information such as those you will find on a World Wide Web. A collection of your documents in the computer made from several programs can be considered as a free-form database. So type of database, there are also operational database and analytical database. Operational database is a dynamic database that is used by an organization in its day-to-day operations. They use to collect data, maintain, modify, and delete data. In analytical data, it is a static database where data is rarely modified. This often is used to store and track historical data to make long-term projects and analysis. Structured data models. Hierarchical models. In hierarchical models, you can visualize as parent, child, and root nodes. And from child nodes, there are many children. Another way of looking at this model by visualizing an inverted tree. The signal table acts as a root of the inverted tree and the other table acts as a branches. To access the data from one of the tables, one has to pass through the root table. The model was popular in IBM information management in 1970s. Next is network model. This model was developed by to address in parts the problem of hierarchical model. As with hierarchical model, it could be visualized as an inverted tree. However, this model allows many inverted trees shared branches but are still part of the same database structure. So as with the parent-child model, the child is allowed to have multiple parents, unlike in hierarchical model access data between from the truth table. In the network model, it's allow access of data from any table. This model was eventually placed by the relational model. Now, relational model. In this, it was developed by Dr. E.F. Cod of IBM in 1970, partly to solve the problem of earlier database problems as well as finding the making of databases less dependent on any application. The term relations, attributes, and domains are used frequently in relational database models. A relation is a table with columns and rows. Attributes are the names given to each column of relational domain in the value which attribute has taken. A relational database is essentially a collection of tables, and if a table database is a collection of tables, there are simply called relational. Next is entity relationship model. This model was written by Peter Chin in 1976. This model is used to abstract conceptual representation of data. Dimensional model. It is a special adaptation using a relational model that is used to represent data in warehouses. Warehouses is essentially storage of all digital data of company or organization. In this model, a single large table of information is used using dimensions and measures. Dimensions tells where, who, and what type of measures would you mean. Quantity is a model that utilizes the relation model as well as the object-oriented programming. Re- Relational Data Management System. RDBMS is a design to create and maintain, manipulate, modify, and delete information in a relational database. As previously mentioned, modern database utilizes the relational data model, and many of today's software caters to this type of structures. Things you can do in data. RDBMS. Create a database, information storage, information retrieval, information management, information analysis, and print and share informations. Let us see some terminology. Data. It is a number of value found and stored in a database. Data is a static because it remains the same until it is modified by a process. Information. It is a data that has been processed, thereby making it relevant and meaningful to persons viewing it. Information is dynamic because it changes relative to the data stored in a database process. Null. It is used to represent a value that is known or missing. A null value is neither a zero nor a blank. Table. It is a main structure in a relationship database. It is composed of attributes and domains. A table almost always represents a subject that can be object. Next is file. It is an organized collection of data about an entity. And an example for a bookstore, a file called branch can contain all the data about a particular bookstore. Record. It refers to a specific person, place, things, or events. Record is also known as a tuple in the RDBMS terminology. It pertains to structure in the database table representing unique subjects. Field. It is the smallest structure of a database from a larger database structure. In a relationship database, a field can store data in a database and represents the characteristics, often the subject to which database resides. View. It is also known as a virtual table. It is called a virtual table since it does not hold data on its own, rather it gets data from a table which is based, and since it's come from other tables, it is composed of several fields. Key. There are These are fields that serve specific purpose within a table. There are two types of keys, the primary key and the foreign key. The primary key is a field that uniquely identifies a record in a table. The foreign key is a special field establish a relationship between two tables. Relationship. They exist when two or more tables have connections. Primary key, foreign key. Types of relationship. When two or more tables are related, they exist between them a specific type of relation. There are three types of relationships. One-to-one relationship. In one-to-one relationship exists between table when only one record of the first table is related to only one record to a second table, and only one record of the second table is related to one and only first record. One-to-many relationship. This relationship exists between tables when one record of the first table can be related to one or more records to the second table, but only one record from the second table can be related to the single record in the first table. This relationship is the most common relationship that exists between tables and helps to reduce or eliminate duplicate and redundant data. Many-to-many relationship. This relationship exists between tables when one record of the first table can be related to the one record of second table. The connections between the two tables will be established and will be result to redundant data in one table. Designing a database. Define the purpose of the database. Consider the question or queries you may want to answer about the storing data. Determine tables that you need in a database. Determine the field that you need in database. Identify unique fields. Determine the relationship between tables. Work by matching data in a key field using fields at the same time. Test the design. Characteristics of a well-designed database. First is modify data is easy. Change to value of one field within the table should not affect the value of the field in other table. Retrieving information must be easy. Extracting the desired information from the table with well-defined relationship should make access and retrieve data a lot faster. Maintain a structure is easy. Change made to table or column should not affect other table. Adding and deleting should be very easy. Things to avoid while designing a database. Spreadsheet. A spreadsheet is a very powerful. It is used powerfully, properly. However, it is designed for a purpose and always will find a purpose within a business or organization. Spreadsheet does not make good relational database because if you really need to acquire and collect, store and maintain, view and analyze, print and share data, then you need tool that is precisely suited spreadsheet view. Secondly, you should also get away from the spreadsheet view mentally. Spreadsheet view seems to offer good meaning to view data. However, the data from may be able to produce a report. A database presented may not be the same. With this, I would like to conclude my topic. Thank you.